Hello, and welcome to another IB Math speedrun with me, Vince. So in this speedrun, we're going to continue going over standard deviation, so let's jump right in. So there's one more thing we need to know about standard deviation that's quite important, and it's the difference between standard deviation of a population and standard deviation of a sample. If we have all the data values in a population, it's fine. So we can already use the definition of standard deviation that we know, which is the sum of x minus the mean squared over the number of terms. But the thing is, if we only have a sample of the population, it's a bit different. So if we have a sample and we want to expand this to the actual population, we have to use the mean of the sample as the mean of the entire population. Other way around. The mean of the sample as the mean of the entire population. And so the thing is, we need to, this is called the unbiased estimator for the population mean. But the thing is, the unbiased estimator for the population standard deviation is different from the sample standard deviation. And it's calculated by actually the same as the top, sum of all the terms minus the mean squared, but instead of dividing by n, we actually divide by n minus 1. And this is because the mean of the sample actually has a standard deviation from the mean of the total population. And so when we calculate the population standard deviation, we need to use the sample mean and predict each deviation from the sample mean. And so if we didn't have, if we have n data points, only n minus 1 of them would be free to vary. So n minus 1 is called our degrees of freedom in a sense. So we have to replace n by n minus 1. If you don't get what that means, it's okay. It's not too important. I mean, it is quite important, but you need to know mostly that you replace n with n minus 1 when we're looking at a sample and trying to apply it to a population. So this is known as Bessel's correction. With that being said, let's jump into some questions. Sorry about that. So let's jump into some questions. So our first question is, we have a question about this guy called Clancy. Clancy recorded the number of minutes late the bus was over a 10-day period. Find an estimate of the population standard deviation for the time in minutes the bus would be late. And so the 10 values he's recorded over the 10-day period are 10, 12, 5, 0, 14, 2, 5, 8, 9, and 6. So the number of terms is equal to 10. The sum of the terms is equal to 10 plus 12 plus 5, 10 plus 12 plus 5 plus 14 plus 2 plus 5 plus 8 plus 9 plus 6. It's equal to 71. And the sum of the squares of the terms is equal to, let me just put into the calculator, 100 squared, 100 plus 144 plus 25 plus 196 plus 4 plus 25 plus 64 plus 81 plus 36 should be equal to 675. So now we need to edit the formula a bit to get the standard deviation. I don't want to sum all the terms. I mean, I guess we could have gone the route of getting the actual number minus the mean squared, but I'm going to edit this a bit because if you notice, if you expand this, what we'll actually get is using the sample where it's over n minus 1, we get f of x squared over n minus 1 minus the number of the mean times the sum of the terms over n minus 1 because the mean being divided by n minus 1. So this should be correct. So if we plug in these values, we get 675 over 9 minus 71 over 9 times 71 over 10. So this is equal to 675 over 9 is equal to 75 minus 71 over 9 times 71 over 10. So I get 56. And so this should be equal to 18.99 effectively. So the square root of 18.99 is equal to around 4.35762. So this should be the answer. Yep, that's the standard deviation. So yeah, that was pretty easy. Okay, and on to the final question already. So where is my text? Here. So it is the summary statistics for a sample of the life of batteries is given. Use the calculate the mean and standard deviation of the batteries. Okay, cool. So we have the number of terms is equal to 25. The sum of the terms is 38,750, and the sum of the terms squared is equal to 60,100,000. Yeah. So let's get the mean. The mean is simply this divided by that. That's equal to 38,750 divided by 25, which is equal to 1,550. So we have the mean as 1,550. Finally, let's get the standard deviation and plugging it into our formula. Oh, my screen. We have 60,100,000 over n minus 1, which is 25 minus 1, which is 24, minus 38,750, effectively squared over 24 times 25. So this should be equal to the square root of 60,100,000 divided by 24. So it's equal to like 2,504,167 minus 38,750 squared divided by 24 times 25. So what I'm getting is around 1,562.5 as the variance, and so therefore the standard deviation should be equal to the square root of this, which is around 39.5 minutes. So yeah, the standard deviation for the batteries would be around that value, and yeah, that sounds about right. So yeah, that was all for the speedrun. I hope to see you in the next one.